For this question, the diagram shows a sketch of the line L1, y equals to 4 over 3x minus 4. So L1 is over here. The line L1 cuts the y-axis at A and the x-axis at B. Now, a quick recap. If I have equation of a straight line, y equals to mx plus c, the m is actually the gradient. So in this case, for line L1, the gradient is 4 over 3. C is my y-intercept. So I know that this y-intercept here is negative 4. Now for part A, they want us to find the coordinates of A and B. Very quickly, we will be able to find the coordinates of point A. It's simply 0, negative 4. To find the coordinates of B, we know that the y-coordinate of B is 0 because it cuts the x-axis where y is equals to 0. So I simply have to substitute y equals to 0 into the equation for L1. So this gives us 4 over 3x equals to 4. And so x is equals to 3. So the coordinates of point B would simply be 3, 0. For part B, they tell us that the line L2 is a reflection of the line L1 along the y-axis. So L2 is seen here. They want us to write down the equation of the line L2. To help us answer this question, we need to know the similarities and the differences between lines L1 and L2. Now, if it's a reflection along the y-axis, we see that the y-intercept of the two lines are the same. So for L2, I know that the y-intercept is also negative 4. And if I have a reflection along the y-axis, the gradient of the line has been changed as well. Instead of it being a positive 4 over 3, it will now be a negative 4 over 3. So I know that my gradient is negative 4 over 3. This will help me write down the equation of line L2 as y is equals to negative 4 over 3x minus 4. For part C, they tell us that C is a point on the y-axis shown on the diagram. So C is over here on the y-axis located below the point A. They want us to find the exact value of cosine angle BAC. Let's go back to the diagram and take a look. So angle BAC is actually this angle over here. They want us to find the cosine of this angle. Now, if you look at the diagram, we see that cosine angle BAC is an obtuse angle. So I'm going to make use of the acute angle, angle BAO, to help us find the exact value of cosine of angle BAC. So I'm going to draw a diagram to help me visualize better. So I have point O here, point B, point A, and point C is below here. Now, since I have the coordinates of points B and points A, I'll be able to know the length. The length of OB is actually 3 units. The length of OA is actually 4 units. So the exact value of cosine of the obtuse angle BAC would then be the negative of the cosine of the angle BAO, the acute counterpart. And that would help us find this exact value. So I will use Pythagoras theorem on the right angle triangle here. AB will then be 5 units. So cosine of angle BAO will simply be 4 over 5. So the exact value of cosine of angle BAC is negative 4 over 5. For part D, they tell us that another line, L3, is given by this equation, 3y minus 4x equals to 7, can be drawn on the same axis. We have to explain why the lines L1 and L3 do not meet. So the first thing that I will do is to rearrange the components of the equation of L3 to give me y is equals to 4 over 3x plus 7 over 3. Now, the reason for me writing it in this y equals to mx plus c form is for me to do a comparison based on their gradient and also their y-intercept. So once I've written it out in this form, y equals to mx plus c, I compare the equations of line L3 with those of line L1. So L1 is actually y equals to 4 over 3x minus 4. So we can see that both of the lines actually have the same gradient, 4 over 3. And on top of that, they do not have the same y-intercepts. So we know that the two lines are parallel because they have the same gradient of 4 over 3. And because the two lines now have different y-intercepts, the two parallel lines will then not meet. So I can write my answer as this.